We're looking at the integral of sine squared of 1 over t all over t squared dt. If you've seen the previous video, then my hope is that together with information that you have from 5a about substitution will allow you to complete this integral. So I'd like you to pause the video and see what you can do with it. I almost finished. I hope you were successful. Since we have sine squared of 1 over t, it made sense to me to let u equal 1 over t, and du is equal to then negative 1 over t squared dt. So by multiplying and dividing by a negative 1, we can substitute and our integral becomes negative integral of the sine squared of u du. Using a power reducing formula, we can replace sine squared of u by 1/2 times the quantity of 1 minus the cosine of 2u. Applying the negative outside of the integral, we can write it as the 1/2 times the integral of cosine of 2u minus 1 du. Integrating the cosine of 2u will bring us a factor of 1/2. Bringing in the factor of 1/2 that is outside of the integral gives us 1/4 times the sine of 2u. We had the minus 1 as part of the integrand as well. That will integrate with the 1/2 out front to negative 1/2 of u. Don't forget our constant of integration plus c. I said we were almost done, and what's left is to back substitute. Our original integral was in terms of t. We now have an answer in terms of u. So we're going to write this as 1/4 times the sine of 2 over t minus 1/2, well, 1 over 2t plus c. Now, something happened just now that I wasn't really thrilled with, but let's talk about it a little bit. When I integrated cosine of 2u, I wrote down 1/4 sine of 2u. Excuse me, that's not true. I wrote down 1/4 cosine of 2u. I forgot to actually integrate the cosine and turn it into a sine. I fixed it on the fly. That's the point I'm making. I was able to fix it because I went back and looked over my work. That's something that I hope that you will do on exams. Go back and look over your work, catch those careless mistakes so that I don't have to. Next up, we have the integral of the tangent squared of x times the cosine cubed of x dx. There's not a lot of nice that can happen when we're looking at a tangent and a cosine. We can use strategies that we saw in previous courses regarding changing trigonometric functions into sines and cosines. You would have seen that when you were proving trigonometric identities in some previous course. With that, I'm going to express the integral as the tangent squared of x is going to be the sine squared of x divided by the cosine squared of x. And then cosine cubed of x, I'm just going to keep writing, and then dx. And we see that two factors of the cosine function will divide out. We end up with the integral of the sine squared of x times the cosine of x dx. At this point, we don't really need to do anything fancy other than to recognize we have a composition, sine squared of x, identify u to be the sine of x, the inside function of that composition, and then du will be the cosine of x dx. We effectively have the integral of u squared du. We'll finish this off by integrating using the power rule. 1/3 times the sine cubed of x plus c.